Now, if you're watching this video and you haven't ever seen the grid method for dividing a polynomial, this is the method I'm going to use, and you might find that it's worth Googling this method, see it in a little bit more detail. But for students that have seen it before, you should be quite confident with setting this up. So what we're going to say is 2x minus 3 multiplied by what gives us the numerator of our fraction. So we want minus 6x squared. So what are we going to times 2x by to give us minus 6x squared? Well, that's going to be minus 3x. Minus 3x times 2x minus 6x squared. Minus 3x times minus 3 gives me positive 9x. Now I don't want positive 9x, I want 13x. So I'm going to have to add 4 more x on. 2x times by what gives me 4x. 2x times by 2 gives me 4x. Then I've got 2x times minus 3, which is minus 6. Now I don't want minus 6, I want plus 3. So my remainder, what I've got left over, is equal to 9. So my final solution, so I've already done enough work here for my 4 marks, is that I can write this as minus 3x plus 2 plus 9 over 2x minus 3. And that is my final solution, and that's worth 4 marks. So as I say, if you haven't seen this grid method before and you've tried a more complex method, that's fine, you can still get marks for it, but that's a really quick 4 marks there. On to part B then, we're asked to integrate the function and show that the solution comes as a set of rational numbers. So obviously we're not going to be integrating this, we're going to be integrating what we've done in part A. So let's integrate between 3 and 6, minus 3x plus 2 and plus 9 over 2x minus 3 with respect to x. So the first two you should remember from last year, core 1, core 2. So add 1 to the power, divide by the new power. So it's minus 3x squared over 2 plus 2x. Now this final term, this one is a bit of an example of where we're integrating f of x as the denominator of f dashed of x. And you should recall that the rule states that we end up with the logarithm of the denominator. So if you differentiate this denominator here, you get 2. Now we don't want 2, we want 9. So what do I need to multiply 2 by to get 9? Well, it's going to be 9 over 2. So 9 over 2 times by the logarithm of the denominator, 2x minus 3. And using that rule, I've then done my integration, which is worth the first 2 marks of this question. So let's remove that theory there. So we're now going to substitute in our limit, 6 and 3. Now, obviously we're looking for an exact value solution here, so it's not going to be as simple as just popping it into your calculator. I would really strongly recommend, particularly if you've just saved time in part A, to take your time with what you're doing here and just write out this step and the next step after that as well, because this next step that I'm now writing, which is why I'm just substituting in 6 and then I'm going to substitute in 3, that gets me my 3rd mark. So if you try and do this without showing that you've clearly substituted in 6 and then you're going to clearly substitute in 3, you're running the risk of making a little slip somewhere in your mathematics and losing yourself a mark. And obviously this exam, core 4, is all about getting as many marks as possible, and not necessarily, as I say, doing silly things with brackets, not necessarily getting every mark. So I've now substituted everything in, so now let's just start tidying up what we've got in front of us. So this first term, 6 squared is 36, times that by minus 3 and divide by 2, we get minus 54. Second term is 12, and I've got 9 over 2 ln of 2 times 6, which is 12, minus 3, so ln 9. So that's my first term, and I'm subtracting from that 3 squared, which is 9, times by 3 divided by 2, which doesn't simplify to anything nicer than 27 over 2, plus 6, plus 9 over 2 ln. Now I've got 2 times 3, which is 6, take away 3, which is 3. So I'm now going to take even more steps through this problem. So I'm going to expand my bracket. And the reason why I'm going to do this in such detail is because it's a negative. And it's so easy to make a mistake here. So I've got minus minus, so I've got plus 27 over 2. I've got minus 6, and I've got plus, sorry, I haven't got plus. I said it was easy to make a mistake. I've got minus 9 over 2 ln 3. So my numeric terms, minus 54, plus 12, plus 27 over 2, minus 6. Plug them all into your calculator, minus 69 over 2. No problem at all. But from there, I've got to add on these two. So I've got 9 over 2 ln 9 minus 9 over 2 ln 3. And obviously that's not what the question asks. It wants a single logarithm. So what you've got to remember from core 2 is that ln 9 can be written as ln 3 squared. And then bring the squared down to the front using the third law of logarithms. So then I've got 18 over 2 ln 3 minus 9 over 2 ln 3. So 18 over 2 ln 3 minus 9 over 2 ln 3 leaves me with 9 over 2 ln 3. Bring back down my minus 69 over 2, my numeric term, and that is my then final solution to that problem.